Okay, let's go over this practice quiz for sections 4.4 to 4.6. Okay, so your quiz, when you take your quiz, you're going to see the 5 cases. So for this first problem, I give you one of the zeros. We know that there's 2 others because the fundamental theorem of algebra, whatever the degree is, that's how many zeros we need. So use the one that I gave you and show that you will get a remainder of 0. Okay, so in this case, I have a 1, 5, 8, 4, and I'm going to go through this synthetic division process, bring down the 1, multiply, add, multiply, add here, multiply, and you do get a remainder of 0. So the numbers left over form a pretty easy quadratic that's going to be really easy to factor. So this first case is just easy factoring. So we know everything's positive. Ways again 2 to add up a 3 is just simply 2 and 1. So negative 2 is the solution and negative 1 is the solution. So you'll see that negative 2 is a repeat. So all 3, negative 2, another negative 2, so that would be a turning point if we'd actually graph this, and then it would pass through the x-axis at negative 1. Okay, so easy factoring. This next one, once again, we're going to have 3 zeros. I give you one of them, so we're going to use the hint to be able to find the other 2. So set the problem up, and like I said, we have to get a remainder of 0. So if on your quiz you're not getting a remainder of 0, you made a mistake. Okay, you must have made a calculation mistake. Bring down this first number, then we multiply, and then we add. So when we add negative 36 plus 27, we're going to get a negative 9. We multiply, we get negative 27. We add, we get negative 10. We multiply, we get negative 30. And there's our remainder of 0. So what's left over is a quadratic that's a little bit harder to factor. So this is the AC method. So I'm going to make my diamond. I'm going to do AC. So I have negative 90x squared up top. And we're not going to give up until we find a combination of numbers that multiply to give us negative 90, but add up to negative 9. So this one may take a while. You start with 90 and 1, doesn't work. 2 and 45 won't work. 3 and 30 won't work. You keep going through. And again, this is where your calculator can help you. You want to think of the factors of 90. Forget about the negative right now. You will eventually see that 6 fits in the 90 15 times. And if the 15 is negative, it adds up to negative 9. Okay, so 15 times 6 is the 90. Since it's negative, I need one negative, I need one positive, and this is the combination that will agree with the middle term. So I'm just going to simply take this and replace my middle term. So we have 9x squared minus 15x plus 6x minus 10, and I split this down the middle. So on the left, what goes into a 9 and 15, the largest number that fits into both is a 3, and you have an x in common, so your GCF is a 3x. That will leave 3x minus 5 inside. Okay, so if you distribute, you're back to the previous line. We must have a 3x minus 5 on the other side, so that would leave a 2 on the outside. Okay, so it looks like 3x plus 2 and 3x minus 5 are our factors. The second we see our factors, we should know the answers. So again, can't do this in your head, do this off this side. You write 3x plus 2 equal to 0 and you solve. Okay, it's going to require that you subtract the 2 and divide by 3. So we have negative 2/3 as a 0, and then this one would require that you add a 5 and divide by 3. So we get 5/3. Okay, so there's our 3 zeros. Okay. Okay, for number 3, we're going to have 4 zeros. Okay, and I give you one of them. So we'll use the one that I gave you. Set this up. Like I said, you must get 0. Okay, you're in trouble if you don't get 0. Bring down the 5, multiply, we add, we multiply, we add, we multiply. 5 times 8 is 40, we get a 0. So now this is a cubic, so it's what's left over is 5x cubed plus 4x squared plus 10x plus 8. When you see 4 terms, you'll be able to factor by grouping. So on the left side, the only thing in common is an x squared. So I factor out the x squared, and I'm left with 5x plus 4 in the parentheses, which means I must see the 5x plus 4 on the other side, which means I factor out a 2. Okay? So x squared plus 2 is a factor, and 5x plus 4 is a factor. Okay, so the second you see the factors, we should be able to quickly find the answers. 5x plus 4 equal to 0, we would subtract the 4, divide by 5. So we get negative 4/5. Okay, and now here, it's a quadratic, which you have to solve by the square root method. So if I want to know what makes an x squared plus 2 0, my first move is to subtract the 2, and then we're taking the square root of negative 2, which is going to be I root 2 and a negative I root 2. So make sure you realize you must have both answers. You must have a positive root and a negative root for you to have all 4 zeros. Okay, so again, hopefully that makes sense. We have plenty of practice to make sure that you can get this. Okay, for number 4, we need 5 zeros, and I give you negative 2. So we have 1, 2, 1, 2, negative 12, negative 24. Okay, so bring down the 1, multiply, you get negative 2, you'll get a 0. This is the one where we see lots of zeros. There's going to be a quartic that's left over. We multiply, we'll get another 0. Negative 2 times negative 12 is a 24 to get a remainder of 0. So the numbers left over form a quartic where we have 1x to the 4th, no x cubes. You don't want x cubes for this case. You need 1x squared, and then you have minus 12. And when you see this on your quiz, the quartic is super easy to factor. Just 2 sets of parentheses. I'll make sure it's just an x to the 4th for you so that you break it up as x squared, x squared. In this case, it's a negative 12, so I need a plus and a minus. And you need a combination of numbers that multiply to give you negative 12, but add up to a 1. So I know it's going to be a positive 4 and a 3. Okay? So now, your remaining answers, so there's 4 more answers. To set this equal to 0, the first move is to subtract the 4, then take the square root. So when you take the square root of negative 4, it's a positive 2i and a negative 2i. So just make sure you understand both answers have to count. So I need a 2i and a negative 2i as my list. And then this one, it's going to be real, but it's going to be an irrational number. So I'm going to add a 3. When I take the square root of positive 3, it's just plus or minus root 3. Okay, so you would have a root 3 and a negative root 3. There's all 5 answers. Okay, so that leaves the 5th case, and that means we're going to use the quadratic formula. So the 5th and final case is where we just need 3 zeros. I give you one of them. So we set this problem up, bring down the 2, multiply, add, multiply, you'll get an 11. Negative 3 times 11, the good news is it's negative 33. That results in a 0. So this quadratic can't be factored. So I'll let you know which one needs the quadratic formula so you're not wasting time trying to factor a problem that can't be factored. Okay, so the quadratic formula, I need my a, b, and c. and all we need to do is substitute everything into the quadratic formula. So it's the opposite of b, so in this case, -3 plus or minus 3 squared minus 4 times a times c, all over 2 times 2. So I just need you to clean up the number underneath the radical. It's called the discriminant. So in this case, I'll ask my calculator what 3 squared minus 4 times 2 times 11 is. And what you're going to see, it's a negative number, so it's negative 79. So I'm going to make it an I root 79. So we have two imaginary answers. So it's -3 plus I root 79 all over 4, and then the minus, -3 minus I root 79 over 4. Okay? So I'll write that up here. So we have -3 plus I root 79 all over 4, and then we have -3 minus I root 79 over 4. All three answers, okay? And just remember, if you would graph this, you would only see one real intercept. So if you would actually type that into this rule into the y equals part of your calculator, you're only going to see it's crossing at -3. You don't see the imaginary, okay? So just keep that in mind. Okay, for number 6, this is the case where we're working backwards. I give you the zeros. You have to be able to write the rule, okay? So it's always nice if I'm willing to give you 0 as a 0, because that just means I have a factor of x. It's always nice just to have a factor of x. Well, then this factor is going to be x plus 5, and then if you have a 0 that's a 4, it's going to be x minus 4. Okay, so this is going to be pretty easy to multiply. I just have to do FOIL for x plus 5 times x minus 4. You'll get an x squared. Your outers and your inners will add up to a 1x. Okay, you can do that off to the side, do it in your head, but -4x and a 5x is just a 1x, and then I'm going to get -20. Okay, and then your final rule is going to be a cubic, because once I distribute the x, I have x cubed plus x squared minus 20x. Okay, and if you have time, type that into your calculator and just take graph, and it better match up with these 3 zeros. Okay, the x-intercepts, it better be this. Okay, so this one, I want you to do a little sketch. Now you can confirm this on a calculator, but I need to see that you factor this correctly. Okay, so in this case, I'm going to split it down the middle. I'm going to factor out an x squared, which will leave x minus 5 in parentheses. I need an x minus 5 in parentheses on the other side, so that means I have to factor out a -4. So then I have x squared minus 4, and then times x minus 5. And again, we're trying to find the zeros. This can be factored. So once you factor everything, I know I'm going to have an x-intercept at -2, a +2, and a +5. Okay, so I need to see the x-intercepts, and then all I need you to be able to do is understand the end behavior. Since this is odd, this graph points in opposite directions, but notice how we see a positive number in front. That tells us it's going to point down on the left, point up on the right. So now, I don't care how you pass through these, so I don't care where you have the turning points. The middle part, I'm not so much concerned with, okay? So just show the 3, in this case 3 x-intercepts, and make sure your graph is pointing in the correct directions as far as the end behavior, okay? So it should be real easy to sketch. And like I said, you can type it in your calculator just to confirm your x-intercepts and the end behavior, but I do need to see the work for factoring. Okay, so then I have a couple more factoring problems for you just to practice. So this one, I tell you to factor completely. If I give you 4 terms, you'll be able to split it down the middle. Now, there's nothing in common with all 4, so there's no GCF to factor out a GCF first. So I just split it down the middle, and then I factor out a 3n squared on the left, which results in a 2n minus 1. Okay, again, get good at factoring out a GCF. And then we better see a 2n minus 1 on the other side, and we can if we factor out a 7. Okay, so 7 is the GCF on the right side. So that leaves us with 3n squared plus 7 times 2n minus 1, and we are finished. Okay, now it would be a good idea to make sure your answer, if you would multiply your back to the original, and it would, this times this is 6n cubed. My outside is the negative 3n squared. 7 times 2n is the 14n. 7 times negative 1 is the negative 7. So it checks by multiplying. Okay? Now, this problem made it a little bit harder. Now, I won't put one like this on your quiz where you have a number in front of the quartic. Okay? So this, we are going to factor. So we're going to come down here and factor. But since I have a number in front and there's no GCF, you're going to have to use the AC method. So I'll quickly review the AC method with you. And again, this is not a nice, setup for anything. Oh, actually, we can make this a little bit easier. I'm just recognizing now there is a GCF. Sorry. I can make this easier. Instead of taking 24 times 9, which is a huge number, I can factor out a 3. So we do have a 3 in common. So we'll come down here and we'll have a 3 on the outside. So we can make this a little bit easier, but like I said, I won't put a problem like this on your quiz. At least your next quiz, you won't see this. So, but still get the work down. We're going to have an 8x to the 4th minus 10x squared plus 3. Okay? So this will make it a lot easier. When I do AC, this is my A, this is my C, I only have to deal with 24x to the 4th. Okay, a lot easier. And we'll come up with a combination that can add up to negative 10. So don't think negative 12 and 2. Okay, that can't work because I need a positive 24. So again, some students get themselves confused. Their brain tells them, hey, I know I can get a negative 10 with a negative 12 and 2. But unfortunately, that would only work if it was a negative 24. And it's not. So it's a positive 24, so you have to think of other ways again, 24. Eventually, your brain will tell you a negative 6x squared and a negative 4x squared is what satisfies that diamond problem. This negative 6 times negative 4 is 24, but adds up to a negative 10. Okay? So all we're going to do then is rewrite this and turn it into a problem like number 8. I'm going to rewrite the negative 10 as negative 6x squared minus 4x squared, and we'll split it down the middle. So on this side, I can factor out a 2x squared. So it's going to give us a 4x minus 3. And the good news is I can easily get, and this will actually be an x squared. We'll have an x squared plus minus 3. Made a little typo here. Let's white out the negative or the plus and make it a negative. Okay? So that means we would have to factor out a negative 1. Okay? So you would have to factor out a negative 1 so that we get a negative 4x squared. Negative 1 times negative 3 is a positive 3. So again, we're not changing the problem. But then that allows us to know our pieces. So our final factors are going to be a 2x squared minus 1. That can't be factored anymore. And then the 4x squared minus 3 is the other factor. Okay? So again, a little bit harder factoring for a quartic than what you're going to see. Okay? So when you see a quartic, it's just going to be x to the 4th. You just break it up as x squared. Okay? And find the other pieces. Okay? So again, make sure you get that work done. Make sure you realize it checks by multiplying. Okay, number 10, I want you to factor this, but this is a problem where you can't split it down the middle. So I'm going to give you a hint. I'm telling you one of the factors. So for number 10, use the fact that I'm telling you x plus 5 is a factor. So when we factor this, that's what I'm looking for. Whoops, you can't see that. So I'm going to use the fact that x plus 5 is a factor, then I'm going to be able to find the other pieces. So what you have to realize is you can use synthetic division. What makes this 0 is a negative 5, 1, 6, negative 1, negative 30. Bring down the 1, multiply, add, multiply, add, multiply, and you get 0. And what's left over is a real easy problem to factor. Okay, so I know it's x and x. I know it's a plus and a minus. Ways of getting negative 6 to add up to a 1x, or 1 in this case, is going to be a positive 3 and a negative 2. Okay, x times x is x squared. Outers, inners will add up to the x. 3 times negative 2 is negative 6. Okay, so that is fully factored. Okay, now this last problem, you can't use synthetic division. So I'm making you review long division. So we can't forget how to do long division. So for the last problem, I'm going to use my factor, and I'm going to go through this process of long division. Okay, so if you forget this or you never mastered it from before, now's the time to force yourself to understand this process. So I only look at this 2x into 2x cubed is simply going to be an x squared. Okay, so it's 2 into 2 is just a 1, so I just need a 1, and x and x cubed, you subtract one exponent. So 3 minus 1, we have an x squared. So then what you have up top must be multiplied by everything on the outside, and we're going to line everything up. So x squared times 2x is 2x cubed, and then it's going to be a minus 3x squared. Once I multiply, I change these to its opposite. So I'm going to use a different color. And then the x cubes are gone. I will have negative 4x squared. I'll bring down the minus 10x, and I'll start this process over again. 2 goes in the negative 4. It's negative 2. X in x squared is just an x. And then I'm going to multiply. Negative 2 times 2x is negative 4x squared. Negative 2 times negative 3 is going to be a plus 6x. Don't forget to change to its opposite. After you multiply, we add the opposites, which is going to result in a negative 16x. Bring down the 24, and this should be the last time, and we have to have a remainder of 0. So if you don't get a remainder of 0, then you didn't divide correctly. Okay, so 2x into negative 16x is going to be a negative 8. When you multiply, you get negative 16x and then plus 24. But you change these to their opposites, and you're going to see that you do get a remainder of 0. Okay? So with the hint, you should now know how to factor the remaining part. And so this quotient right here, super easy to factor. I know it's plus and minus because it's a negative 8. And then ways of multiplying numbers to give you negative 8 that add up to a negative 2. I need the 4 next to the minus, the 2 next to the plus sign. Okay, and if you do that, it checks by FOIL. It'll get x times x is x squared. Outers, inners will add up to a negative 2x. 2 times negative 4 is negative 8. So that's how I would factor a problem like that. Again, this would be impossible to solve by, or factor by grouping. So if I give you something like that, I would have to give you a hint for you to get started. Okay, so you're only going to have 9 questions on your quiz, so make sure though that you understand these 11 before you take your quiz. Okay, so be prepared, ask for help, look over the warm-ups that we did, the extra practice that we did in class, and you should be more than ready to do well on this 4-4 to 4-6 quiz. Thanks for watching. Take care.